Colors and shades of Mars. Mars is commonly known as the red planet, but its surface appearance is not uniform. The color of the surface varies from red to orange to brown, depending on geographical features such as plains, dune fields, volcanoes, and ancient water channels. There are also seasonal white polar caps that can turn into visible clouds, and occasional dust storms that can cover the entire planet. Furthermore, Mars' distance from the Earth and the Sun changes as both planets follow their orbits, affecting how we perceive the planet's color. NASA and other space agencies often enhance images of Mars taken by spacecraft to reveal details not easily visible in the original images. These enhancements can make colors appear brighter or more saturated than to the human eye. While these images provide valuable scientific information, they may not accurately represent how Mars would appear in person. Viking 1 orbiter, 1980. The largest canyon in the solar system cuts a wide swath across the face of Mars. Named Valles Marineris, the Grand Valley extends over 3,000 kilometers long, spans as much as 600 kilometers across, and delves as much as 8 kilometers deep. By comparison, the Earth's Grand Canyon in Arizona, USA is 800 kilometers long, 30 kilometers across, and 1.8 kilometers deep. This global mosaic was created from over 100 images of Mars taken by Viking 1 orbiter on February 2, 1980. The images are projected into point perspective, representing what a viewer would see from a spacecraft at an altitude of 2,500 kilometers. Mars Global Surveyor, 1999. Mars Daily Global Image from April 1999. 12 orbits a day provide the Mars Global Surveyor MOSI, Mars Orbiter Camera, wide-angle cameras a global snapshot of weather patterns across the planet. Here, bluish-white water ice clouds hang above the Tharsis volcanoes. Mars Global Surveyor, 2001. The 2001 Great Dust Storms. June 10, 2001. July 31, 2001. September 24, 2001. Hubble, 1995 to 2007. Mars Near Oppositions, 1995 to 2007. This composite of images from the Hubble Space Telescope shows the changing size of Mars as visible from Earth every few years. Note how the polar caps and atmosphere also change over time, which affect Mars' overall color. This illustration shows the relative positions of Earth and Mars at the last 7 Martian oppositions from 1995 through 2007. Opposition occurs when the Sun and Mars are on exact opposite sides of Earth, resulting in a full phase for Mars, similar to a full moon. The images of Mars show the planet's apparent relative size at each opposition, as viewed by the Earth-orbiting Hubble Space Telescope. Orbits of the inner planets are to scale. HST, 2003. The Hubble Space Telescope, HST, snapped this portrait of Mars within minutes of the planet's closest approach to Earth in nearly 60,000 years. This image was made from a series of exposures taken on August 27, 2003. In this picture, the red planet is 55,757,930 kilometers from Earth. The striking features in this portrait are Olympus Mons, the oval-shaped object just above center, the largest volcano in the solar system, and Solis Lacus, an immense dark marking also known as the Eye of Mars, below, right, and the southern polar ice cap. Rosetta, 2007. True color image of Mars taken by the European Space Agency, ESA, Rosetta spacecraft during its February 2007 flyby of the planet from a distance of about 240,000 kilometers. Generated using the onboard OSIRIS instrument orange, red, green and blue color filters. Mars Orbiter Mission, 2014. Mars Orbiter Mission (MOM) captured this first global view of Mars with its Mars Color camera on September 28, 2014, from a distance of 74,500 kilometers. Hope, Emirates Mars Mission, 2021. April 24, 2021. The Tharsis Montes can be seen with Olympus Mons just to the left and Vias Marineris at the right. Mars Express, 2019-2022. This is a simulated view of Mars from a vantage point 2,500 kilometers above the colossal Vias Marineris Canyon system, with enhanced color and contrast. It is a composite of red, green and blue filter mosaics with the color band values stretched individually, and has a spatial resolution of 2 kilometers per pixel. Darker gray-toned areas of Mars represent gray-black basaltic sands of volcanic origin, lighter patches show clay and sulfate minerals, and the large scar across the planet's face is Vias Marineris. The mosaic was created using data from Mars Express's high-resolution stereo camera, HRC. Gathered from 90 images at higher altitudes, of 4,000 to 10,000 kilometers. There are multiple factors involved in capturing images by spacecraft cameras. While the cameras on spacecraft, robotic explorers, and telescopes play a role, they are not the main factor in the colors you see. The varied images are actually due to physical explanations, including the amount and density of dust or particulates in the planet's atmosphere at the time, the physical size of the dust grains or particulates that are present, which should vary in both place and time, and the position of the Sun relative to the photograph taken. The variations in what we observe when we gaze at the planet can reveal some subtle yet crucial characteristics of this world and its atmosphere.